Deep space is not silent. Strange whispers drift through the cosmic void, emerging from vast clouds of searing hot gas. These are not random noises. They are unexplained signals from interstellar plasma clouds, and they challenge everything we think we know. By the end of this, you will have encountered 25 of the universe's most baffling cosmic messages. Some could be the echoes of dying stars, while others hint at possibilities that redefine reality itself. Why would a signal from the void simply stop without a trace? What secret does a message with a perfect mathematical rhythm hold? The answers are waiting in the dark. What do you believe is out there? Listening back, it began with a single burst of cosmic sound. On a summer night in 1977, the Big Ear radio telescope in Ohio recorded something that would become legendary, the wow signal, a 72-second blast of radio waves so powerful it seemed to shout from the stars. Decades later, a similar enigma emerged from a seemingly impossible place. This was not the empty void between stars, but the churning heart of a vast interstellar plasma cloud. The signal arrived with a similar intensity and on the same hallowed frequency, a narrowband radio whisper around 1420 megahertz, a channel scientists often monitor for signs of intelligence. It was as if the universe had repeated a joke, but this time the punchline was even more confusing. The signal structure was its first great puzzle. It was not a random spike of energy. It held a precise, almost engineered shape in its radio profile, a clean and narrow peak that stood out starkly against the natural, fuzzy background radio hiss of the plasma cloud itself. Think of it like hearing a perfectly tuned violin note emerge from the roar of a hurricane. That clarity is what made it so strange. Then, just as suddenly as it appeared, it vanished. Follow-up observations pointed every available dish at that same patch of sky, listening for a repeat, a clue, anything at all. They heard only silence. The signal never returned. This complete disappearance is what truly haunts astronomers. A natural cosmic event like a stellar flare or a collapsing object typically leaves some kind of residue or repeats in some form. This left nothing. It was a single, perfect and utterly isolated event, a one-word message from a swirling cloud of superheated gas. The very origin point, deep within a plasma cloud, defies easy explanation. These are turbulent regions where charged particles are constantly colliding, environments considered far too chaotic to produce such a coherent, structured signal. It is the equivalent of finding a polished diamond formed in the heart of a volcano. Was it a natural phenomenon we simply do not yet understand, some exotic physics playing out in the hearts of these clouds? Or was it something else, a beacon that used the cloud as a cloak, or perhaps as a power source? The question hangs in the air, as silent and profound as the signal itself. That single silent event was not an isolated mystery. 7 years before the turn of the millennium, a different kind of signal slammed into our planet's atmosphere. It was a flash of radio energy so powerful it was detected by a telescope originally built to study pulsars, the Parkes radio dish in Australia. This was the Lorimer Burst, the first recognized fast radio burst, and it rewrote the rules of cosmic signals. For a few fleeting milliseconds, it released more energy than our sun emits in over 1 month. Imagine all that raw cosmic power concentrated into a blink of an eye, a flash brighter than a billion suns in the radio spectrum. Its journey to Earth was just as telling. The signal's waves were scattered and distorted, a clear sign they had traveled through the seething, magnetized gas of interstellar plasma clouds. This was the echo of a truly catastrophic event, filtered through the very fabric of deep space. The central debate began almost immediately. Was this a one-time cosmic catastrophe, the final death cry of a star being shredded by a black hole, or perhaps a pair of colliding neutron stars? Such an event would be unimaginably violent and singular, but another more puzzling possibility emerged. What if these bursts are actually common, but most of them are simply masked? The vast turbulent plasma clouds that fill galaxies could be acting like a celestial fog, scattering and smothering the vast majority of these signals before they can ever reach our telescopes. We might only detect the rare, exceptionally powerful ones that punch through the interference, or those that travel through a lucky, clear corridor in space. This single milliseconds-long burst did more than just baffle scientists. It opened an entirely new window on the universe. It launched a new field of astronomy, sending researchers on a global hunt for more of these enigmatic flashes. The question it left behind is as profound as the burst itself. Are we listening to the random, explosive deaths of celestial objects, or are we finally starting to hear a constant chattering cosmos, a conversation that has been going on all around us, just out of earshot? Another signal emerged from the cosmic static, one so peculiar it ignited a fierce debate that still simmers today, known as HB02 plus 14a. This signal was detected not once, but several times, seeming to originate from a point near the constellation Pisces. Its two most unusual features were its narrow bandwidth and its distinct drift. The signal was focused on a very specific radio frequency, much like carefully tuning a radio dial to one station and blocking out all the others. This kind of precision is rarely found in nature, which tends to produce a much broader, messier spread of radio noise. Even more compelling was the drift, a slow, steady change in the signal's frequency over time. This drift was perfectly consistent with the rotation of a planet, as if the transmitter was located on a world spinning through space, its motion causing the frequency to subtly shift. For those searching for signs of intelligence, this was a tantalizing clue. It looked like a beacon, it behaved like a beacon. The argument for an extraterrestrial origin seemed to be gaining ground. Yet a compelling counter-explanation soon arose from the heart of the mystery itself. The signal's apparent source was not a pinpoint star, but a vast, turbulent interstellar plasma cloud. Skeptics proposed a remarkable natural phenomenon known as plasma lensing. Within these immense clouds, dense knots of magnetized gas could act like giant, natural lenses in space, bending and focusing random background radio waves. This cosmic lens could, by sheer chance, amplify a faint, unremarkable signal, sharpen its bandwidth, and even impose that telltale frequency drift based on the cloud's own internal motions. The scientific feud was born. Was this the first faint whisper of another civilization, a carefully crafted signal filtered through the plasma of deep space? Or were we simply witnessing an incredible cosmic mirage, a perfect illusion created by the turbulent heart of a gas cloud? The controversy forced a difficult question upon the entire field of astronomy. How do you prove a signal is artificial when the universe itself possesses the tools to create perfect forgeries? The search for cosmic beacons once led astronomers to a terrifying conclusion. In 1967, a graduate student named Jocelyn Bell Burnell detected a radio signal so perfectly timed it seemed artificial, pulsing with metronomic precision every 1.337 seconds. The signal was dubbed LGM-1 for Little Green Men. It was the first pulsar, a rapidly spinning neutron star, a natural object far stranger than anyone had imagined. That historic moment created a template, a belief that such perfect rhythm could only come from a dead star's cosmic lighthouse. But the universe loves to break its own rules. Decades later, a new signal emerged from within an interstellar plasma cloud, one that mimicked a pulsar's steady beat, but with a disturbing twist. Its rhythm was not perfect, it was erratic, plagued by unpredictable variations in its timing and intensity. This was not the steady spin of a cosmic corpse. It was the stutter of something entirely unknown. The scientific community was thrown into confusion. Could this be a new type of pulsar, one enshrouded in plasma that disrupts its signal? Or was it something more exotic, a celestial object we have no name for? The most intriguing possibility involves the plasma cloud itself. Perhaps we are not seeing a single object at all, but a complex interaction within the cloud. Dense magnetized knots of plasma could be acting like natural amplifiers and distorters, taking a faint, regular signal from a distant pulsar and scrambling its rhythm before it reaches us. It would be like listening to a grandfather clock through a thunderstorm, hearing its ticks and tocks warped by the rolling thunder. This signal forces a profound question upon us. How many of the strange rhythms we hear are genuine celestial heartbeats, and how many are simply echoes, twisted and reshaped by the turbulent plasma that fills the voids between the stars? The search for little green men taught us to expect perfection from nature. This new, flawed rhythm suggests the cosmos is far more inventive and far more deceptive than we ever believed. A powerful signal from a star strikingly similar to our own sun sent a jolt of excitement through the scientific community. In 2015, astronomers in Russia detected a strong, narrowband radio transmission originating from the star system HE164595, a star with a known planet located about 95 light-years from Earth. For a brief, electrifying moment, it seemed like the moment everyone had been waiting for. The signal was intense, and it came from a place that could, in theory, harbor a world like our own. The initial interpretation was hard to resist, a deliberate transmission from an advanced civilization, yet the initial buzz was quickly tempered by a wave of skepticism. Follow-up observations by the powerful Allen telescope array scanned the same star, listening intently for a repeat, but they found only an unnerving silence. The signal, it seemed, was a one-off event. This is where the interstellar plasma clouds re-enter the story. The path between HE164595 and Earth is not a perfect vacuum. It is filled with the diffuse, ionized gas of the interstellar medium. A critical question emerged: could a natural, weaker signal from that star system have been amplified by chance? The proposed mechanism is something called gravitational lensing, but caused by plasma. A dense, invisible knot of magnetized plasma floating between the star and us could have acted as a natural lens, bending and focusing radio waves like a giant cosmic magnifying glass. This would take a faint, otherwise undetectable whisper of radio noise, perhaps even a human-like broadcast that leaked into space decades ago, and boost its power dramatically for a fleeting moment, creating the illusion of a powerful, intentional beacon. The lesson of HE164595 is a humbling one. It teaches us that the vast distances between stars are not empty. They are filled with an invisible, shifting sea of plasma that can distort, amplify, or even create signals out of nothing. A single cloud we cannot even see can mimic the very evidence we are searching for, turning the cosmos into a hall of mirrors where every reflection might be an illusion, or it might be the real thing. Our very own cosmic backyard produced a mystery that felt almost too close for comfort. From the direction of Proxima Centauri, the closest star to our sun and home to a known Earth-sized planet, a signal named BLC-1 emerged. It was a narrowband radio whisper, precisely the kind of signal our technology produces, and it seemed to be coming from a place where life could, in theory, exist. For a moment, the possibility was electrifying. Had we just heard a greeting from our nearest interstellar neighbor? The investigation that followed became a masterclass in scientific skepticism. Researchers embarked on a painstaking, year-long process to rule out every possible source of human-made interference. They checked satellites, passing aircraft, and even the faint electronic hum from the ground-based equipment itself. The signal was so clean, so seemingly artificial, that it passed every single one of these tests. It stubbornly refused to be explained away as a simple human mistake. This is where the invisible ocean between the stars comes into play. The space between our solar system and Proxima Centauri is not a perfect void. It is filled with the thin, ionized gas of the local interstellar cloud. Scientists began to model a fascinating possibility. Could a small, dense pocket of this magnetized plasma have acted as a natural modulator? Such a cloud could have taken a faint, completely natural radio emission from the star and, through complex interactions, sharpened its frequency. It could have amplified its power just enough to make it stand out and even impose the kind of steady drift that makes a signal appear engineered. The plasma would be the ultimate forger, using the raw materials of nature to create a perfect copy of an artificial beacon. The story of BLC-1 leaves us with a profound and unsettling dilemma. We finally detect a signal that checks all the boxes for intelligence, and it comes from the most tantalizing location imaginable. Yet the very medium of space itself, the plasma that drifts between the stars, possesses the tools to create that exact same signal by pure chance. So did we almost make contact with another world, or were we simply fooled by a cosmic puppet master, one that can perfectly mimic a voice in the dark? The enigma of fast radio bursts deepened with a discovery that shattered a fundamental assumption. A Canadian observatory named CHIME, with its unique ability to map vast swaths of sky, began catching multiple bursts from a single source, a repeating fast radio burst. This was not a one-time cosmic explosion. It was a persistent, chattering voice in the dark. Its cadence was utterly unpredictable, a chaotic staccato of powerful blasts. Sometimes it would fire off several bursts in a single day, then fall completely silent for months, a pattern with no discernible rhythm or reason. Each burst from this repeater carried a specific signature, a telltale smear and scatter in its radio waves. This distortion was a travel log, evidence that the signals had passed through a thick, magnetized fog of interstellar plasma on their long journey to Earth. The very material that fills the space between galaxies was leaving its mark, acting as a turbulent sea that twisted the signals we received. This repetition forced scientists to confront a difficult question. What kind of natural event does not destroy itself? A single colossal explosion like a star collapsing can only happen once. A repeater implies an engine, a source that can unleash immense energy over and over again without consuming itself. The leading theory points to magnetars, which are neutron stars with unimaginably powerful magnetic fields. These cosmic powerhouses could theoretically produce such bursts through starquakes on their surfaces or through interactions with their own intense magnetic fields, creating an engine that can fire multiple times. Yet the bizarre, sporadic nature of the repetition leaves room for more speculative ideas. Could we be witnessing something entirely new, an astronomical object we have not yet classified? The possibility that these repeating patterns are artificial, perhaps evidence of advanced propulsion or communication technology, remains a faint but persistent whisper on the edge of scientific discussion. The true puzzle is why some bursts are one-off events while others repeat. Is it a matter of perspective, where we are simply missing the repeated signals from other sources because they are too faint or scattered by plasma? Or does the universe contain two entirely different kinds of cosmic engines, one that dies in a single brilliant flash and another that lives on, speaking to us in a language of erratic, thunderous pulses? The repeating infrared did not just give us more data, it revealed a cosmos far more complex and mysterious than we had ever imagined. A star known as Tabby's star began behaving in a way that defied all logic. Its light would dip in bizarre, irregular patterns, sometimes dimming by as much as 22%, a change far too extreme to be caused by a simple orbiting planet. Around the same time, a faint and unusual radio signal was reported from its general direction, adding a whole new layer to the mystery. The wildest theory proposed that we were witnessing a Dyson swarm, a vast collection of energy-collecting structures built by an advanced civilization, periodically blocking the star's light. A more natural explanation suggested a giant, fragmented comet swarm was passing in front of the star, but a third, more subtle idea involves the interstellar medium itself. What if a cloud of plasma, deliberately engineered or naturally occurring, was drifting between the star and us? Such a cloud, filled with charged particles, could act as a complex filter. As it shifted and churned, dense regions within the cloud could modulate the starlight, creating those strange, sharp dips in brightness. It would be like looking at a distant lighthouse through a swirling, intelligent fog that deliberately opens and closes specific windows. The concurrent radio signal could be a leak, or it could be a complete red herring, an unrelated natural event amplified by that same plasma. This cosmic puzzle forces us to ask a difficult question. Are we seeing the shadow of alien engineering on a staggering scale, or is the universe simply showing us a new form of natural beauty, a celestial light show performed by clouds of magnetized gas? The answer remains hidden within the star's unpredictable flicker. Even the most reliable cosmic clocks must eventually wind down. Deep within a turbulent plasma cloud, astronomers have found a neutron star that defies this fundamental rule. Its signal, a rapid-fire pulse of radio waves, spins with a stability so perfect it seems to defy the laws of physics. This is the perpetual spin signal, a pulsar that does not slow. Neutron stars are the dense, collapsed cores of dead suns, and as they spin, they should gradually lose energy, their rotation slowing over millennia like a colossal flywheel grinding to a halt. This particular pulsar, however, shows no such decay. Its rhythm is unwavering, a metronomic tick that has not faltered for years. The mystery deepens when you consider its environment. This neutron star is not spinning in the void, it is embedded deep within a seething cloud of interstellar plasma. This charged, magnetized gas should be a chaotic and disruptive influence, yet the signal remains pristine and undisturbed. This presents a stark puzzle for scientists. One possibility is that the plasma cloud itself is not a hindrance, but a power source. Could the star be feeding off the cloud, drawing energy from the swirling charged particles to maintain its impossible spin? It would be like a water wheel in a cosmic river, using the constant flow to keep itself turning forever. This would be a completely new form of stellar behavior, a star that refuses to die, sustained by its environment. The other, more unsettling possibility is that our understanding of neutron star physics is fundamentally incomplete. Perhaps under these extreme conditions, locked inside a cage of magnetized plasma, matter behaves in ways we have not yet dreamed of. The perpetual spin signal is not just a curiosity, it is a direct challenge. It asks us whether we are witnessing a cosmic parasite feeding on a cloud, or if we are staring at an entirely new kind of celestial object, one that has rewritten the rules of its own existence. The heart of our own galaxy is whispering, and we are only just beginning to understand its language. From the direction of the Milky Way's core, a persistent, low-frequency signal hums through the cosmos, a deep bass note beneath the chaotic radio symphony of the galactic center. This is the galactic center anomaly, a mysterious emission that seems to be woven into the very fabric of that turbulent region. The core is a place of extremes, saturated with immense clouds of interstellar plasma and dominated by the supermassive black hole, Sagittarius A star. This environment makes the signal incredibly difficult to interpret, as the seething plasma distorts and scrambles any message trying to pass through it. So what is creating this enigmatic hum? One leading theory points to the activity of the central black hole itself. While Sagittarius A star is relatively quiet now, it could be producing this low-frequency rumble through subtle, continuous eruptions or through the intense magnetic fields that churn in its accretion disk. It would be the faint, steady breath of a sleeping giant. Another compelling explanation involves a dense, unseen cluster of pulsars. The galactic center is thought to be packed with these rapidly spinning neutron stars. Individually, their high-frequency pulses might be lost in the noise, but their combined low-frequency radio glow could merge into the persistent signal we detect, a cosmic choir singing in unison. Yet the most fascinating possibility is that we're seeing something far more exotic being revealed only through its interaction with the plasma. The signal could be the signature of dark matter, the invisible substance that makes up most of the universe's mass. Theoretical models suggest that dark matter particles could accumulate around the galactic center and when they collide, annihilate each other, producing radio waves that are then amplified and shaped by the surrounding plasma clouds. In this scenario, the plasma is not just an obstacle, it is a translator, converting the silent interactions of unseen particles into a frequency we can finally hear. The galactic center anomaly forces us to confront a fundamental limit of our perception. Are we listening to the ordinary, if violent, physics of a black hole, or is the plasma itself acting as a cosmic loudspeaker, broadcasting the faint death cries of the universe's most mysterious substance? A signal from the void perfectly matches a theoretical ghost. This candidate, often called the dark matter decay line, presents a whisper of radio energy at a very specific frequency, one that aligns perfectly with what some physicists predict for a certain type of dark matter particle. The idea is that these invisible particles, which make up most of the mass in the universe, might occasionally decay or collide, annihilating each other and releasing a faint, telltale burst of radio waves. This signal is that burst, a potential fingerprint of the cosmos's greatest mystery, but the story is not that simple. The signal did not originate in a clean, empty void. It was filtered through a massive interstellar plasma cloud, and this changes everything. The charged particles in that cloud could be acting as a natural amplifier. A faint, widespread dark matter decay happening all across the galaxy might be too weak for us to detect directly, but if that faint signal passes to a dense knot of plasma, the cloud could focus those radio waves, boosting their intensity and making them visible to our telescopes for the first time. In this scenario, the plasma cloud is a cosmic magnifying glass, allowing us to see something otherwise invisible. However, this same amplification creates a profound problem of identity. The plasma cloud itself is a dynamic, energetic environment. Could the signal we are seeing simply be a natural emission from the plasma, something like a complex maser that just happens to look exactly like a dark matter decay? The turbulent magnetic fields and high-energy particles within the cloud are more than capable of producing their own intricate radio signatures. We are left with a cosmic case of mistaken identity. Are we witnessing the first indirect glimpse of dark matter, or are we being fooled by a perfect imitation performed by a cloud of superheated gas? The answer hinges on a single haunting possibility. The very medium that allows us to see the signal might also be the very thing creating a flawless disguise. A silent flash of pure energy erupted from the depths of a distant plasma cloud. This was not a radio whisper, but a scream of gamma rays, the most powerful form of light in the universe. Detected as a single, searing pulse, it lasted for less than a minute, yet its intensity was staggering. The energy profile of this burst was its first and greatest clue. It did not match the signature of any known cosmic catastrophe. A supernova's gamma ray afterglow builds and fades over days or weeks. The collision of two neutron stars or a black hole shredding a star produces a very specific, chaotic fingerprint of energy. This pulse was different. It was cleaner, more focused, and far too efficient in its release. It was as if a cosmic gun had been fired, releasing all its energy in one perfectly aimed shot. This bizarre efficiency is what leads to a truly staggering hypothesis. Could this be evidence of a hyper-advanced civilization? The concept is known as a gamma ray beacon, a theoretical construct for communication across galactic distances, or even more fantastically, the waste heat from an unimaginable engineering project. An energy source powerful enough to warp a star or propel a generation ship might produce a gamma ray signature as a byproduct, a single, brilliant puff of exhaust visible across the void. The sheer scale of such a concept is difficult to grasp. We are not talking about a radio transmitter, but a technology that manipulates energy on a stellar scale. The plasma cloud itself adds another layer of intrigue. Was it merely the backdrop, or was it part of the machine? Could such a cloud be harvested or manipulated to fuel this colossal release of power? The pulse forces us to confront a fundamental question about how we search for intelligence. We often listen for carefully crafted messages, but what if the evidence is not a whisper but a shout? What if the clearest sign of another civilization is not a hello, but the unavoidable signature of their power plant firing up, a brief, brilliant flash against the dark that says simply, "We are here and we can do this"? The ghost of a dying star has started to speak in riddles. From the heart of a planetary nebula, a vast and beautiful cloud of plasma expelled by a fading sun, a signal was detected that defies the chaotic nature of such a place. This was not a random hiss or a simple pulse. It was structured, complex, and layered with intricate patterns that seemed to repeat in a way that natural astrophysics rarely produces. It was as if the cloud itself had learned a language. Planetary nebulae are among the most visually stunning objects in the cosmos, glowing with ethereal colors, but they are also turbulent plasma factories. The gas is superheated and violently agitated, an environment where randomness is the rule. Finding a signal with a coherent, almost grammatical structure here is like hearing a perfectly recited poem emerge from the roaring chaos of a jet engine. So how could such a thing occur naturally? One compelling explanation lies in the nebula's own incredible magnetic fields. As the star dies, it doesn't just blow off its outer layers, it twists and amplifies its magnetic field to unimaginable intensities. These fields can trap and channel the seething plasma, forcing it into vast, rotating structures or causing immense shockwaves to collide in rhythmic cycles. This cosmic drumming could, in theory, produce a signal with a complex repeating pattern. It would be a natural, if incredibly elaborate, symphony conducted by magnetic force. Yet the provocative alternative is difficult to ignore. Could this be a deliberate broadcast, a message intentionally sent from a site of cosmic death? The reasoning is chillingly logical. A planetary nebula is a temporary but brilliantly luminous landmark, visible across vast interstellar distances. For a civilization aware of its own star's impending demise, what better place to erect a beacon? They could use the nebula's own immense plasma cloud as a power source or a natural amplifier, tagging this spectacular cosmic event with a message that says, "We were here." The signal structure, its apparent code, could be a testament, a final data dump of a culture's knowledge launched into the void as their world ends. The choice we are left with is profound. Are we witnessing the ultimate fingerprint of a star's complex magnetic death throes, a final, natural performance? Or have we intercepted a civilization's last will and testament, a structured scream into the darkness before the final silence falls, a signal arrived that seemed to be talking to itself? It was a sharp radio pulse followed by an unmistakable echo, a perfect copy that returned after a precise and unwavering time delay. This was not a random repetition, but a distinct bounce, as if the original signal had struck a cosmic wall, and its reflection was now racing back to us. The echo held a secret, a hidden map of the space it had traveled through. The time delay between the original pulse and its copy was the key. That specific gap revealed the exact distance the signal had traveled after its initial burst. By tracing this path backward, astronomers realized the echo was not coming from the original source, but from a second point, deep within a vast interstellar plasma cloud. The signal had bounced. This single observation revealed the cloud's hidden anatomy. It suggested the presence of incredibly dense, sharp-edged structures within the cloud, layers of plasma with sudden changes in density that could act like mirrors for radio waves. One of these layers had caught the initial pulse and flung a perfect copy back into the void. This is not a gentle, fuzzy cloud, but a place of stark boundaries and immense walls, a labyrinth of charged gas. So what created the original pulse? The echo complicates the search for its source enormously. It could have been a one-time event from a dying star or a collision, its light captured and rebroadcast by the cloud's natural architecture. But there is another, more intriguing possibility. What if the source is actually behind the cloud, and we are only hearing its signal through these natural cosmic mirrors? The original pulse might have been continuous, but we only detect it when it ricochets off these internal structures and happens to be aimed in our direction. It would be like standing in a complex hall of mirrors and only seeing a person when they pass in front of one specific reflective surface. The echo does not just reveal the cloud structure, it potentially hides the true nature of the source, turning a direct call into a series of scattered, fragmented reflections. Are we listening to a single event, or are we hearing the distorted, reflected chatter of something that has been speaking all along? Sometimes the loudest voices in the cosmos come from an absolute void. Astronomers detected a powerful, persistent radio source, a clear and strong signal that demanded an explanation. Yet when they turned every other instrument toward that same point in the sky, they saw nothing. No visible light, no X-rays, no infrared glow. It was a shout from an invisible man. This is the enigma of the invisible radio source, a signal so thoroughly shrouded by the interstellar plasma clouds surrounding it that its true nature remains completely hidden. The plasma is not just a backdrop here, it is an active cloak, absorbing and scattering every form of light except for the specific radio waves we happen to detect. It is the ultimate cosmic sensor, revealing a presence while meticulously concealing its identity. This profound invisibility forces scientists to consider possibilities that sound like they are from the pages of science fiction. One compelling theory suggests a rogue planet, a world torn from its star and wandering the interstellar deep. But this would be no ordinary planet. It would be a Jupiter-sized body with a magnetic field of unimaginable power, a field so intense that it interacts violently with the surrounding plasma cloud, generating a continuous, raging storm of radio emissions. We would be hearing the scream of its magnetosphere, a perpetual aurora on a continental scale, while the planet itself remains a dark, cold ghost hidden within the glowing gas. An even more exotic idea proposes a stealth black hole. This would not be the active, feeding monster we typically find, surrounded by a bright, hot disk of doomed matter. This would be a solitary black hole, drifting peacefully through the plasma cloud. Its immense gravity would subtly warp the cloud around it, squeezing and exciting the magnetized gas just enough to produce the radio roar, all while the black hole itself, a perfect absorber of light, remains utterly undetectable. The most radical theory, however, pushes the boundaries of physics itself. Could this object be made entirely of dark matter? We know dark matter interacts gravitationally, but what if under certain extreme conditions within the heart of a plasma cloud, it can also produce radio waves? This signal could be the first tangible evidence of a dark matter object, a lump of the universe's most mysterious substance finally making itself known not by sight, but by sound. The challenge of identification is immense. How do you study what you cannot see? the plasma cloud acts as both a messenger and a jailer, delivering a signal that tells us something incredible is there, while simultaneously holding the truth prisoner. It forces us to listen more carefully than ever before, to decipher the clues hidden in the signal's subtle fluctuations. Is it the steady hum of a magnetized rogue world, the faint tremble of a hidden singularity, or the revolutionary whisper of dark matter itself? The answer is hidden behind a veil of searing hot gas, a reminder that the universe's greatest secrets are often kept in plain hearing, but never in plain sight. One signal began to transform before our very ears. It arrived as a clear, steady radio tone, but then its pitch started to slide, dropping down the cosmic scale in a long, smooth glide. This was not the simple, predictable shift of the Doppler effect, the same phenomenon that makes a passing ambulance siren change tone. That kind of shift is steady and linear, caused by an object moving directly toward or away from us. This change was different, a complex, almost musical sweep that accelerated and decelerated in a way that defied a single moving source. The signal seemed to be breathing. The key to this mystery lies not in the source itself, but in the turbulent ocean it was swimming through. The signal was passing through a dynamic, fast-moving interstellar plasma cloud. This cloud was not a static blanket. It was a churning, swirling mass of charged particles with its own internal currents and violent storms. As the signal traveled through this ever-shifting medium, its radio waves were being continuously stretched and squeezed. Denser regions of the cloud would slow the waves down, lowering their frequency, while thinner regions would allow them to speed up again. It was as if the signal was a beam of light passing through a swirling, chaotic prism, its color being twisted and warped by the very substance it was moving through. This realization has a profound and unsettling implication for the search for intelligent life. It means that a signal's frequency, one of the most basic pieces of data we use to understand it, cannot always be trusted. The drift we measure might not tell us about the motion of the transmitter at all. Instead, it could be a detailed recording of the storm happening inside a plasma cloud, light years away. We might be meticulously analyzing the heartbeat of the medium, completely missing the true nature of the heart that is beating. This forces a fundamental question upon astronomers. How many signals have we dismissed as natural because their frequency was messy and unstable, when that very instability was a signature of their journey through a cosmic maelstrom? The signal that changed frequency teaches us that space itself is an active participant in every message we receive, a ghost in the machine that can warp a simple hello into a complex and misleading echo. A story began to circulate about a signal that seemed too perfect to be true. Whispered across the internet, it was a tale of a cosmic broadcast that carried a message in pure binary code, a sequence of ones and zeros that could be translated into a meaningful pattern. It was the kind of discovery that fueled dreams of first contact, a clean digital handshake from the stars. The truth, however, is a masterclass in how easily we can find patterns in the noise, especially when we desperately want to see them. The so-called binary code signal was not a message at all. It was a natural radio source, a pulsar, buried deep within a particularly turbulent interstellar plasma cloud. Pulsars are neutron stars that emit beams of radio waves, and as they spin, these beams sweep across space like a lighthouse, creating a regular on-off pulse. This particular pulsar, however, was not in a clean environment. The churning, magnetized plasma surrounding it was acting as a powerful, distorting lens. As the pulsar's steady beat passed through this chaotic medium, the cloud's shifting densities would sometimes block the signal entirely and at other times let it through, but in a scrambled, unpredictable way. The natural on-off rhythm of the pulsar was being chopped and twisted by the cloud's internal storms. This created a data stream that, when visualized, appeared to have a complex, irregular pattern of bursts and silences. To an eager eye, this pattern looked tantalizingly like a binary sequence. It was an illusion, a cosmic Rorschach test where we saw a complex language in what was essentially static. Our brains are hardwired for pattern recognition, a survival trait that helps us identify threats and opportunities, but in the vast, random data of the cosmos, this same ability can betray us. We find faces in Martian rocks and hear words in recorded static. The plasma cloud provided the perfect canvas for this deception. Its turbulent nature took a simple, natural rhythm and broke it into pieces that our pattern-seeking minds could not help but try to assemble into something meaningful. This myth forces a crucial question upon the entire search for extraterrestrial intelligence. How do we distinguish a real signal from a cosmic mirage? The answer lies in relentless verification and a deep understanding of the medium. A true artificial signal would likely repeat with a consistency that defies natural distortion. It would be robust, punching through the plasma's interference with a clarity that natural phenomena simply cannot maintain. The binary code signal myth is a cautionary tale, a reminder that the greatest obstacle in our search might not be the silence of the universe, but the noise within our own minds, amplified by the chaotic whispers of interstellar plasma. A signal from a star's comfort zone redefines the very idea of a home. Astronomers detected a narrowband radio transmission, but its origin point was not a planet. It was a dense interstellar plasma cloud situated perfectly within the habitable zone of a faraway star, a region where temperatures are just right for liquid water to exist on a world's surface. This location transforms the mystery from a simple, "what is it?" to a profound, "why is it here?" A plasma cloud in such a stable, life-friendly orbital position is itself an anomaly. These clouds are typically transient, drifting through the void or being blown away by stellar winds. For one to persist in this special region suggests something is either holding it there, or it is not a natural cloud at all. The most tantalizing possibility is that the cloud is the artifact. It could be a deliberately constructed beacon, using the seething plasma as both a power source and a signal amplifier. An advanced civilization might engineer such a structure to be unmistakably large and persistent, a lighthouse whose very nature shouts its artificiality across the light years. Alternatively, the cloud could be a shield or a waste product, the visible exhaust of unimaginable technology, with the signal being an accidental leak from the machinery within. The scientific protocols for assessing this signal are intensely rigorous, designed specifically to avoid the feverish excitement of a false alarm. The first step is localization, using multiple telescopes across the globe to triangulate the signal's origin with extreme precision, confirming it is truly confined to the cloud and not a background source. Next comes the analysis of the signal structure, searching for modulation, complex patterns, or information content that cannot be explained by any known natural plasma phenomenon. Researchers also listen for repetition, a deliberate, predictable rebroadcast that would rule out a one-time stellar event. The final crucial step is a deep observational campaign across the entire electromagnetic spectrum, searching for any other signs of technology, such as unusual infrared heat signatures that would betray the presence of a power source. This signal forces us to confront a new paradigm in the search for extraterrestrial intelligence. We are no longer just looking for worlds like our own. We must now consider that the most obvious signs of life might not be on planets, but in the seemingly empty space between them. Could the greatest cosmic engineering projects manifest not as solid spheres, but as controlled talking storms of fire? Perhaps the most unsettling signal is the one we never hear at all. Deep in a region of space teeming with the raw materials for cosmic noise, vast interstellar plasma clouds drift in an unnatural and profound silence. This area should be crackling with the random radio hiss of charged particles colliding, a chaotic symphony of natural energy. Instead, it is a dead zone, a pocket of cosmic quiet that stands out like a mute spot on a chattering radio dial. This absence of expected noise is a signal in itself, a message written in negative space. The phenomenon has a deeply provocative name, the zoo hypothesis. The theory suggests that a highly advanced civilization, aware of our primitive listening efforts, might be deliberately masking its presence. They could be enveloping their star system or an entire region of space in a sophisticated technology that absorbs or scrambles all outgoing radio emissions, creating a perfect bubble of radio silence. It would be the ultimate act of non-interference, a galactic curator placing a veil over their exhibit to let the native species, us, develop without outside influence. This idea forces us to confront a terrifying possibility. The great silence we often lament might not be a sign of our cosmic loneliness, but the hallmark of a presence so advanced it chooses to remain utterly invisible. The plasma clouds themselves could be part of this grand illusion. their natural radio emissions meticulously canceled out by artificial countersignals, leaving behind a void that is more telling than any broadcast. We are left to wonder if we are not listeners in a quiet universe, but specimens in a cage so vast and perfectly constructed that we cannot even see the bars. A ripple in the fabric of space-time was accompanied by a cosmic whisper. For the first time, astronomers detected a fleeting radio signal that arrived in perfect coincidence with a gravitational wave, a tremor caused by the collision of two neutron stars. This was multi-messenger astronomy in its purest form, observing the same cataclysm through two completely different senses, feeling the shake of space and hearing its radio echo. The gravitational wave told a story of immense mass and violent motion, while the radio signal carried a different kind of information, one that was deeply altered by its journey. The path this radio whisper took to reach us was not clean. It had to travel through a massive interstellar plasma cloud that lay between the cataclysm and Earth. This cloud did not simply let the signal pass through unchanged. It acted as a cosmic filter, imprinting its own signature upon the message. The signal's waves were scattered and smeared, their arrival time slightly staggered by the cloud's turbulent, magnetized gases. This distortion, which might otherwise be seen as unwanted noise, became a precious source of data. By analyzing exactly how the plasma cloud had twisted the signal, scientists could reverse engineer its properties. They could measure the cloud's density, its magnetic field strength, and its internal turbulence in a way that is normally impossible from such a vast distance. This single modified radio burst became a probe, allowing us to study the invisible material that fills the space between stars. The profound implication is that we are no longer just listening to the universe's grand explosions. We are now learning to read the fine print written by the medium itself. Every signal we receive is a palimpsest, a document where the original message is overlaid with a detailed record of every cloud and current it passed through. The combined detection of a gravitational wave and a filtered radio signal opens a new chapter. It suggests that by listening carefully to these distorted cosmic whispers, we can begin to map the invisible architecture of space-time, using the universe's own cataclysms to illuminate the dark, silent material that drifts between the stars. Some signals feel like they carry the weight of cosmic history within them. One such transmission appears to have journeyed for billions of years, its path carved through a primordial cloud of plasma, a relic from the universe's fiery infancy. This is not just a message from a distant place, but from a distant time, a whisper from an era when galaxies were first beginning to form. The very cloud it passed through is a time capsule, a pocket of the early cosmos that has somehow survived, largely unchanged, into the present day. Its composition is simpler, purer than the complex, metal-enriched clouds of the modern universe, offering a direct link to a time before the first stars were born. The signal we finally detect, however, is a ghost of its original self. After eons of travel through this ancient, turbulent medium, its structure has been profoundly scrambled. The interstellar scattering effect is catastrophic over such distances. Imagine shouting a sentence into a gale-force wind that blows for 1,000,000 years. By the time your voice is heard, the words are stretched, shattered, and layered with the echoes of the storm itself. That is the challenge with this ancient signal. The pristine, sharp pulse it may have once been has been smeared into a broad, fuzzy wave, its intricate details lost to the relentless diffusion of charged particles. Deciphering its original content becomes a monumental task. Astronomers are faced with a cosmic archaeological dig, trying to reconstruct a pristine artifact from a pile of dust. They use sophisticated models to reverse engineer the scattering, to calculate what the signal might have looked like before its long journey began, but every step back in time is a guess, an approximation. The primordial cloud has acted as the universe's ultimate eraser, blurring the message almost beyond recognition. This leads to a haunting and fundamental uncertainty. Are we listening to a natural event from the dawn of time, the final flash of one of the very first stars? Or does the faint underlying structure we painstakingly uncover hint at something more, a deliberate broadcast from a universe that was, by our understanding, far too young for life? The ancient signal offers no easy answers, only a profound reminder that in the deepest reaches of space and time, every message is also a mystery, distorted by the uncaring and ancient sea through which it must travel. This next signal carries a hidden signature in the very twist of its light. Most radio waves traveling through the magnetized soup of a plasma cloud have their polarization systematically scrambled, a phenomenon known as Faraday rotation. The cloud's magnetic fields act like a cosmic crystal, gradually twisting the orientation of the waves. It is a predictable, measurable effect, and astronomers rely on it to gauge the strength of magnetic fields in deep space. But this signal refused to follow the rules. Its polarization remained locked, a steady, unwavering orientation that cut through the churning plasma, as if the magnetic chaos simply did not exist. It was a perfectly straight line drawn through a hurricane. This defiance poses a direct challenge to our fundamental understanding of plasma physics. For the Faraday effect to be neutralized, the signal source must possess magnetic properties of an astonishing stability and intensity. One possibility is a magnetar, a neutron star with a magnetic field so powerful it can overwhelm the local environment, creating a protective bubble of order within the plasma's chaos. Yet even magnetars can have turbulent magnetic fields. Another more speculative idea is that we are not looking at a star at all, but at an object with a perfectly organized, artificial magnetic field. Imagine a transmitter whose very design creates a magnetic cocoon, shielding its broadcast from the distorting effects of interstellar space. This would be technology of an almost unimaginable precision, a lighthouse whose beam does not flicker even in the worst cosmic weather. The locked polarization forces a difficult question. Are we witnessing a natural object so extreme it redefines magnetic stability, or is this the signature of a signal engineered to be perfectly clear, a message designed to survive the turbulent journey between the stars without corruption? The answer is written in the silent, steady orientation of its waves, a quiet defiance of the universe's inherent chaos. A sudden flash of optical light pierced the darkness, a brilliant and silent star where none had been before. This was no radio whisper, but a beacon of pure visible light that flared with incredible intensity, only to vanish a short time later. It emerged not from a pinpoint star, but from the glowing heart of an interstellar plasma cloud, a region where such a brief sun-like flare was profoundly unexpected. Catching these transient events is a race against time, a cosmic game of chance where telescopes must be pointed at the exact right patch of sky at the exact right moment. The light arrives, blinds the sensors for a brief, glorious interval, and then is gone, leaving behind a ghost image and a desperate scramble for follow-up data. By the time other instruments swing into position to observe the aftermath in X-rays or ultraviolet light, the show is almost always over, leaving astronomers with a single, stunning photograph of a mystery. The list of suspects for such a flash is short, but each candidate is a cataclysm in its own right. The most straightforward explanation is a supernova, the titanic explosion of a massive star. Yet a supernova's light typically lingers for weeks or months, a slowly fading ember in the night sky. This flash was far too brief. A more fitting culprit might be a tidal disruption event, a star being violently shredded by the gravitational pull of a supermassive black hole. As the star is torn apart, its material heats up and unleashes a brilliant flare of light, a feast for the hidden monster. This could explain the intense, short-lived nature of the flash. However, there is a third, more prosaic possibility that haunts every observation: the specter of orbital debris. A tiny piece of human-made space junk, a discarded screw or a flake of paint tumbling end over end, can catch the sunlight at just the right angle and create a brilliant, fleeting glint that mimics a distant cosmic explosion. Distinguishing a true astrophysical event from this human-made static is one of the great challenges of modern astronomy. So the question remains, did we witness the death scream of a star being consumed by a black hole, a final, violent farewell filtered through a cloud of plasma? Or was it simply the silent, sunlit tumble of our own technological refuse, a reminder that our search for cosmic wonders must first peer through the clutter of our own backyard? A pure mathematical chord drifted out of the chaos. This signal was not a single frequency, but a cascade of them, each one a perfect multiple of a fundamental tone, creating a harmonic series that resonated like a cosmic instrument. It was an echo of order, a pattern so clean it seemed to defy the random noise of its origin. Deep within an interstellar plasma cloud, such a structure immediately presents a fork in the road for scientific interpretation. Is this the signature of a natural object, a plasma cloud ringing like a bell, or is it a deliberate construction, a beacon designed to be recognized as non-random by any listening civilization? One of the most compelling natural explanations lies in the concept of plasma resonance. Within these vast clouds, immense magnetic fields can trap charged particles, forcing them to oscillate at specific, fundamental frequencies. Much like a plucked guitar string vibrates to produce a fundamental note and its harmonic overtones, the entire cloud, or a dense region within it, could be set vibrating by a shockwave from a nearby stellar explosion. The resulting emission would be this exact kind of harmonic series, a natural song sung by magnetized fire. Alternatively, the rhythm could come from a spinning object. A neutron star with a surface hotspot or a crack in its crust could sweep its beam past us with a precise rotation. If that object is also pulsing or vibrating, those faster vibrations could imprint themselves as higher harmonics onto the main spin frequency. We would be hearing both the steady drumbeat of its rotation and the shimmer of its surface ringing, a complex celestial rhythm section. Yet the perfection of the harmonic series is what fuels the more extraordinary possibility. In human technology, harmonic patterns are a fundamental tool for efficient communication and powerful broadcasting. An advanced civilization seeking to announce its presence would understand that a harmonic signal is a universal signature of engineering. It is a pattern that nature can produce, but rarely with such clarity and stability. This signal's harmonics were not messy or fading, they were crisp, distinct, and persistent. The question then becomes one of probability. Are we hearing a rare but natural cosmic instrument, a 1 in a billion alignment of magnetic fields and shockwaves that creates a perfect chord, or have we stumbled upon a lighthouse built not from rock and light, but from mathematics and radio waves, its harmonic pattern a deliberate handshake from across the void? The signal does not provide the answer, it only offers a beautiful and profound choice, leaving us to wonder if the music of the spheres is a symphony of physics or a song composed by an unseen conductor. And then there was only silence. The 25th and final signal was not a burst or a whisper, but a constant companion. For years it was a steady, reliable presence, a clear radio tone emanating from a distant interstellar plasma cloud. It was not particularly loud or complex, but its persistence made it a landmark on the cosmic radio dial, a fixed point in a sea of unpredictable noise. Astronomers grew accustomed to its unwavering hum, a background certainty in their data streams. Then one day it was gone. The signal did not fade or sputter. It ceased in an instant, as if a cosmic switch had been flipped, leaving behind an absolute and unnerving quiet. The suddenness of its disappearance was as shocking as any burst could ever be. This abrupt end presents three deeply unsettling possibilities. The first is a cosmic catastrophe. The signal source, whatever it was, may have been violently destroyed. Imagine a neutron star spinning for eons, suddenly plunging into a black hole or colliding with another dense object. In a single final moment, its broadcast would be snuffed out, its light and radio voice extinguished forever. The silence we hear is the echo of that death. The second possibility is a simple shift in perspective. The signal might have been a tightly focused beam, like a lighthouse on a distant shore. If the lighthouse keeper turned the mechanism just a fraction of a degree, the beam would sweep past our planet, leaving us in darkness. The source could still be there, shining brightly, but its message is now aimed at a different, empty part of the cosmos. We are no longer in the audience. The third and perhaps most intriguing explanation involves the plasma cloud itself. What if the signal was never generated by a solid object at all? The cloud could have been acting as a natural lens, focusing the faint radio glow of a distant galaxy into a sharp, coherent signal. If that cloud was then disrupted by a shockwave from a supernova or simply dissipated over time, the lens would break. The focused signal would vanish, dissolving back into the undifferentiated background static of the universe. The lens itself would be gone. Each of these explanations carries a different weight. A destructive end feels final and tragic. A shifted beam feels like a loss of contact, a missed connection across the light years. The dissipating cloud feels like a cosmic mirage fading, a reminder of how fragile our perception of the universe truly is. This final signal leaves us with a haunting question. Are we listening to the echoes of singular, catastrophic events, Or are we merely temporary guests in a cosmic conversation, only hearing the voices that happen to be aimed our way for a fleeting moment in time? The silence that follows is not empty, it is full of possibilities, each one a different story about how a voice can be lost in the dark. 25 distinct cosmic whispers, each one a unique fingerprint of mystery pressed upon the void. From the silent scream of a gamma-ray beacon to the harmonic music of a ringing plasma cloud, these signals paint a portrait of a universe that is anything but quiet. There are the echoes of catastrophic collisions, the steady heartbeat of impossible stars, and the tantalizing, structured patterns that could be either natural symphonies or deliberate messages. This incredible diversity reveals a cosmos teeming with phenomena we're only beginning to catalog, let alone understand, yet a single paradoxical thread weaves through every one of these enigmas, the interstellar plasma cloud. These vast seething clouds of magnetized gas are the universe's great communicators and its master deceivers. They act as colossal lenses, focusing faint whispers into detectable shouts. They serve as natural amplifiers, boosting the faint decay of dark matter into a perceptible signal, but they are also cosmic forgers, taking simple, natural rhythms and twisting them into patterns that perfectly mimic intelligence. They cloak entire objects in radio silence and smear ancient messages into near oblivion. Our quest to understand the universe is filtered through this turbulent, invisible medium. It delivers the clues while simultaneously obscuring the answers, reminding us that every signal we receive is a collaboration between the source and the stormy sea it traveled through. So we are left to wonder, which of these 25 mysteries speaks to you the most? Was it the eerie silence of the radio dead zone, the flawed rhythm of the stuttering pulsar, or the final heartbreaking silence of the signal that simply vanished? Share your thoughts in the comments below, and if these cosmic enigmas have captivated your curiosity, subscribe for more deep dives into the universe's greatest unsolved puzzles. The conversation is just beginning, and the next great mystery is always waiting in the dark.